In this illustration, we intend to simulate the cyclic analysis of drilled flange connection in the Abaqus software. You can observe in the right picture the laboratory model, and in the left picture the simulated model in the Abaqus software can be observed. As it can be observed in the picture, a number of holes have been drilled on the beam flange. In this example, a cyclic loading will be applied to the beam, and then its hysteresis diagram will be drawn. In this picture, the hysteresis diagram obtained from the Abaqus software has been compared with the experimental result. Actually, we intend to simulate this article in the Abaqus software. The article is entitled Experimental and Analytical Investigation of Drilled Flange Connections with Radial Drilling Patterns. I will click on Create Part. I intend to create geometric shape of continuity plate. These continuity plates are used in the column and are 15 millimeters thick, and you can observe the place of these continuity plates. Select Shell and Planar, Continue. I will draw a square. The size of this side is equal to 300 millimeters, and the size of this side is equal to 300 millimeters as well. Done. Create instance. I will enter the geometric shapes of beam and column into the assembly section and OK. I will click on Rotate Instance. Select column and rotate that 90 degrees about x-axis. I will click on Translate Instance. Select the beam. Done. First, select this point. Then this one and OK. I will click on Translate Instance, select the beam, done. I will click on Create Section. I intend to define the thickness of column. Here I will select Shell and Homogeneous, continue. The thickness of column is equal to 15 millimeters. Here I will select the 15 millimeter plate and OK. I will click on Assign Section. In the next step, I will enter Step module. Click on Create Step. Select Dynamic Implicit. Continue. Done, and consider the number of 4 elements for them. In the next step, I will click on Assign Mesh Control. Select these surfaces. Done. Here I will select Medial Axis, then Quad and OK. Then I will click on Mesh Part and yes. In the next step, we intend to draw the hysteresis diagram of the model. Actually, we intend to draw this diagram in the Abaqus software. In this diagram, the horizontal axis is drift, the unit of which is radian, and the vertical axis is moment, the unit of which is ton meter. I will click on Create XY Data, select ODB, Field Output, Continue. Here select Unique Nodal first. I'll select RF2, then select U2. Here I'll select Set 6, that is related to the place of cyclic loading. Save. I'll click on Create XY Data, select Operate on XY Data, Continue. Here I will select all reaction forces, then select Sum option and click on Add to Expression. I'll click on Combine. First select U2, then select Total Force and click on Save As. Here you observe the hysteresis diagram of the model in which the horizontal axis is displacement and the vertical axis is force. I will transfer this diagram to the Excel software. The first column is displacement, the unit of which is millimeter. The second column is force. You should only note that in the diagram having been drawn in the article, the horizontal axis is drift and the vertical axis is moment. Here the diagram having been drawn with green color is the one having been obtained from the Abaqus software. As you observe, the results obtained from the Abaqus software are really close to the results mentioned in the article. In fact, the results obtained from the Abaqus software have a good conformity with the laboratory results, indicating that the question has been simulated correctly in the Abaqus software. In the right picture, the formation of the laboratory sample is observed. Actually, you can observe in the right picture what we have simulated in the Abaqus software. Also, in the left picture, the hysteresis diagram we had already drawn in the Abaqus software can be observed.